In a previous section, we were able to integrate functions that were powers of x. But what happens when we want to integrate more complicated functions? Before we jump into that, let's talk about differentials. If y equals f of x is a differentiable function with derivative dy dx is equal to f prime of x, then the differential of x is dx and the differential of y is dy, where dy is equal to f prime of x dx. Example 1 says, find dy if y is equal to x to the 7th power minus 5x cubed plus 2x. So we want to find dy, and that's equal to f prime of x times dx. So we have 7x to the 6th minus 15x squared plus 2 dx. Part B says find du if u equals 11x cubed plus 5x squared. So du would equal 33x squared plus 10x dx. Let's talk about the power rule for integration. Recall that if y equals u of x to the nth power, then the derivative of that is dy dx is equal to n times u of x to the n minus 1 power times the derivative of u of x, because we need to use the chain rule. This helps us inform us that going in the reverse direction, the integral of u of x to the nth power times u prime of x dx is equal to u of x to the n plus 1 power over n plus 1 plus the constant of integration, where n does not equal negative 1. If we use that fact, or if we use the fact that du is equal to u prime of x dx, we can rewrite the power rule in the following way. If u is equal to u of x, then the integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c, where n does not equal negative 1. Let's look at some examples of how we're going to utilize the power rule for integration. Example 2 wants us to evaluate the integral of 9x squared times the quantity 3x cubed plus 1 to the 4th power. So the first thing that we need to do in these types of problems is we need to decide what our u function is going to be. And here I'm going to make u equal to 3x cubed plus 1. And the reason that I made it 3x cubed plus 1 is if I find du, then that's going to be equal to the derivative of our u function times dx. So that's going to be 9x squared dx. Now, notice that 9x squared dx is right here. So I have 9x squared dx there, and I can substitute that with du. So that's exactly what I'm going to do. And then I'm going to substitute the thing inside the parentheses for u. So if I rewrite this integral, 9x squared times 3x cubed plus 1 to the 4th power dx, I can rewrite that as the integral of 3x cubed, I can rewrite it as u to the 4th power du, because remember the 9x squared and the dx, if I replace those give me the du value. So I've rewritten it, and now I can just use the power rule. So that is equal to u to the 5th power over 5 plus c, and I just need to substitute back in the u value, which was 3x cubed plus 1 to the 5th power over 5 plus c. So that is our final answer for this indefinite integral. Example 3 says evaluate the integral of 3x times the square root of 5 minus x squared. And again, it takes some practice, but I've been doing this for a long time, so I know that I want to make my u value equal to the thing under the square root, 5 minus x squared. And the reason that I know that is because when I take the derivative and find du, my derivative ends up being negative 2x dx. And although there isn't a negative 2x, there is an x here and a dx here, so I can simplify that. So if I divide both of these by negative 2, then I get du over negative 2 is equal to x dx. And now since x dx is here and it's also here, I can make that substitution now. So I'm going to rewrite this. I'm going to factor out the 3, or take it outside of the integral symbol. So I have the square root of 5 minus x squared times 3 dx. And again, oops, not 3 dx, I meant x dx. And this thing here, I can substitute with that. So if I rewrite this now, I have 3 times the integral of the square root of u times du over negative 2. And the 1 over negative 2 I can factor outside of the integral symbol. So that's going to be negative 3 over 2 times the integral of the square root of u du, like that. And then from here, we want to use the power rule. So I'm going to rewrite that using a power. So I have negative 3 halves u to the 1/2 power du. And then that will equal negative 3 halves times I'll increase the power by 1, which will give us 3 halves. And then I want to divide it by 3 halves plus c. And we want to do some simplification now. So I'm going to have negative 3 halves times the reciprocal of 3 halves, which is 2/3. And I'm going to replace u with 5 minus x squared to the 3 halves power plus c. And then finally, this will leave us with negative 5 minus x squared to the 3 halves power plus c. Example 4 says evaluate the integral x squared times the quantity 3 minus 10x cubed to the 4th power dx. So again, we want to figure out what our u value is. And one thing that I forgot to mention is that if you take a regular calculus class, you'll often hear this process or this technique called u substitution. I spelled that wrong. U substitution. So if you need to look that up and want to practice more problems or whatever, the technique is called u substitution. So we want to figure out what our u value is. And in this case, we're going to make it 3 minus 10x cubed. And if we find du, that ends up becoming negative 30 x squared dx. And I'm going to divide both sides by negative 30. So now we get du over negative 30 is equal to x squared dx. And the reason I divided by negative 30 on both sides is because I have the x squared here and the dx here. So let's rewrite this. I have 3 minus 10x cubed to the 4th power times x squared dx. And now I can replace this thing with du over negative 30, and this is what I originally made u. So let's rewrite that. That's going to equal the integral of u to the 4th power du over negative 30, and then I can factor out negative 1 over 30 outside of the integral symbol. And now I can use the power rule. So I have negative 1 over 30 times u to the 5th power over 5 plus c. And that's going to equal negative 1 over 150 times 3 minus 10x cubed to the 5th power plus c. Example 5 says evaluate the integral of 18x squared times the 4th root of 6x cubed plus 5. So here I'm going to make u equal 6x cubed plus 5, and then I'll make du 18x squared dx. And I don't need it to manipulate that at all because here's the 18x squared and here's the dx, so I can directly replace that with du. And so my integral will now be the 4th root of u, or I'm going to write it as u to the 1/4 power du. And that will equal, I want to increase the power by 1, so that's going to be 5/4, and then divide by 5/4 plus c. And I want to multiply by the reciprocal, so 4/5 times 6x cubed plus 5 to the 5/4 power plus c. And that is our final answer.